So in today class, we are going to see the staircase pressurization for a high-rise building which has two basement, one ground floor, one mezzanine floor, and 7 floors. So normally, what happened? I am submitting this Excel for authority approval always, and I am going to teach you the same with the practical design issues which I faced in my design career. So when it comes to staircase pressurization, 95% of the videos in the YouTube, if you see, they will follow exactly same as this CED documents, and will repeat the same what you see the calculation and this format. It will be everywhere in the video. So when you do the actual calculation, you will get some design mistakes. So for example, when you do the actual calculation, actual submission to authority or local civil defense, you can see the yellow color highlighted one. So you must prove that your calculation complies to this maximum door opening force requirement as per standard requirement, which you can't see in those videos because which is not covered in this CED document. So in today video, I will tell you how to do this exact calculation for this stair 1, and you people must perform the same similar calculation for stair 3 and submit to me individually before this weekend. Okay. So in today class, first I will tell you some important points required for the calculation as per NFPA 92, and additional theory and installation I will cover in the next class. So then we will go for the Excel calculation. Then you will find out the exact fan sizing for the staircase. So for the staircase pressurization, we will normally follow NFPA 92 smoke management system requirement. So like you see here, we are using different type of fans, for example propeller fan and centrifugal fans like this. And come to the design. So the propeller fan, if you use the propeller fan, you can directly inject the air from the top. You don't need multiple ducts here. So this method is called as a single injection method. And coming to multiple injection, you can see the duct which is passing in the shaft area, and after that it will discharge the air in different levels. So this is called as a multiple injection. So first of all, as per NFPA 92, the roof propeller fans shall be permitted to be used in single injection system provided that the wind seals are provided because of the wind effect. But coming to other fans like a centrifugal or inline axial fan, I can use the fan for the either single or multiple injection system. So when it comes to the calculation, the first important thing is we have to find out the minimum pressure difference across smoke barriers. That means the staircase and the nearby area. And see, for example, if your building is a sprinkler building, irrespective of any height, you have to provide minimum 12.5 Pascal pressure difference in the stair zone. And if it is not sprinkler building, suppose your building is doesn't have the sprinkler, and that time you have to decide is based on the ceiling height. Means for example, if you see our drawing, like you see here, we have the building heights are there now. So based on the floor height, you need to decide the minimum pressure difference. So let me ask you one question here. For example, if you see our practical project here the size is like 4,800. Okay, and if you go above, for example here it is 4,500, because when you see practical project, the basement height and the first floor height, ground floor height, the heights for the full building is not same. Then the question will come to your mind, then on what basis I need to decide this sprinkler height, because it's mentioned 9 feet means this is the minimum pressure difference, 15 feet means this is the pressure difference. So in your project you have different height. So how you will finalize this one? So I will tell you the answer when you go for the Excel calculation now in the few minutes. So here are some important points you need to consider. The minimum pressure difference is 0.18 inch per water column between the stair and adjacent accommodation space as per NFPA 92A. If you see 92A, this 92A section was withdrawn on 2011. After that we have only NFPA 92, not NFPA 92A. And maximum pressure difference is 0.37 inch of water column as per IBC, International Building Code. And the important thing is the airflow velocity must not be greater than 1 meter per second through the doors. Okay, when 3 doors are open. Actually, one more thing, I will come to this point. When 3 doors are open, it's very easy to explain you. And maximum force required to open any door at a door handle must not exceed 30 pounds or 133 Newton. So this is the important point we have to verify after performing all the calculation. That I will show. That also I will show in the Excel file. So first let me tell you this point. When 3 doors are open, the velocity must not exceed more than 1 meter per second or 200 feet per minute. So for this point you can see this one, the calculation shall take into account two number or three number of doors to be opened simultaneously. For example, if you go to UAE life safety code, they will tell to consider two number of doors, okay, at the time of fire. That means if two number means one door at the time of at the area of the floor. For example, if the fire is happening at this point, we are assuming that one door is continuously opening at this point and one door is opening at the exit point. So the UAE life safety codes tell you need to consider two doors for the calculation. When it comes to Qatar, they will tell you three number of doors for the calculation. Means at a time three doors are opening, like that you need to assume. For example, this is the fire zone, means one door at this one door at the exit point, one more door whether it is up or down near to the fire zone. So in the calculation for the Qatar, we are normally considering three door. In the UAE life safety code, we are considering two door, and based on the international building code, we need to consider three doors. So because this is very important, if you are increasing the door, the fan capacity will go very high. So first in the Excel, we need to see this point, the number of doors opening into the stair. So coming to our project, so if you see here, basement 2, basement 1, ground level, so one door for each level of stair. So I will consider total 12 levels are there. For example, if I go to the section drawing here, so if you see here, basement 2, basement 1, so you can count the door number 1, 2, then if you go above, like if you go above, you have the ground floor, then you have the mezzanine floor. So coming to the higher level, like level 01, level 02, and going to this side, you can see here level level 3. So level 2, level 3, level 4, level 5 is not shown here. Level 5 is continuation 6, 7, and till the roof level, because here in the roof also we have one door here at this point. So we need to consider this door also in the calculation. So total we have 12 door for this project. So I consider here 12 doors, and the number of doors, stair doors open during exiting. So that means, as I told you, the UAE life safety code, we need to consider minimum two doors. Coming to the Qatar, it's 3 door. Coming to IBC international building code, it's 3 door. So if you have local civil defense requirement saying 2 or 3 doors, you need to follow this number of doors here. And height of the stair door and width of the stair door. So if you go to our drawing here, so this height and width I measure from this door. For example, if you see here, so the width of the door, this is the width of the door and this is the height of the door. So I measured from this value directly. So it is like 80 inches and 44 inches. And crack length considered for the stair door, because normally what happen when you fix the door and you need to fix in the frame. For example, I'll show you in the example. So if you see here, so this is the door, for example, and we normally fix over the frame. So there will be some gap between the door and frame. So because of this reason, this crack length we normally consider. So if you see down, I have mentioned in the notes also, crack length is considered as 0.006 feet or 0.1 as a constant value. 0.1 inch is a constant value. So I consider the same 0.1 inch as a constant value only for the crack length. So the next important step is the length of the stairwell and the width of the stairwell. So here the length and width of the stairwell, you know that from it is from basement 2 to roof level we have, but you know that from basement 2 we don't have one level, one sizes, and basement 1 sizes, it will not be there. It will be a constant stairwell from basement 2 to top level. So what I will do, I need to measure the width and depth, width and length here. And here important thing you need to see when you go for the design, we need to measure the internal dimension. For example, here the internal dimension from here to here, okay, we don't need to consider the external dimension from here to here, only the internal dimension we need to measure, that is 6000 you need to consider. Coming to this dimension, you can see the internal dimension starting from this point to this point, so 2800 and 6000. So these two dimensions you have to consider. And here I mentioned the answer, for example, length of the stairwell in inches and the width of the stairwell in inches. The next one is the height of the stairwell. This is the question I asked you earlier also, because if you see here at this level it is 3600 height, this level 4800, and this level ground level 4500. So how you will measure the height if you have the different value like this? So that is very important here. So if you go to our design, so what I did here is, you can see This value I consider first of all the total height from basement to the top level. Then I divided with the number of floor to get the average, because sometimes the people will consider the highest value. That is not correct. If you consider the highest value, the answer will go like over design only, because in some floors we have the lower values now. So it is not correct. So first you need to understand here what is the total height and how to measure the total height from in the drawing. So here for example, if you go down, this is the basement 2, we have minus 8.4, and you have to be careful that the value I am measuring from the bottom of this slab. Okay, at this level, not at this level. We have to consider from the value from this point. So this point to the ground level, first it is 0, and this height is minus 8.4. So we have to add this one, and going to the top level of the building. So if you see here, the top level of the building, the upper roof level, so they have shown till this point. So but in the calculation we need to consider the inner point. Okay, so the inner height till here, this point. So we need to subtract this slab thickness, that is not here, it is 250 mm. So I consider the same 250 mm here also for this project. So I need to subtract this 250 mm from here. I need to measure the height from here. That means 44.650 minus this 0.250 250 mm plus I need to add the basement height, that is 8.4 meter. So you will get the answer. So for example, if you see here 52.8, how I got 44.65 minus 0.25 plus 8.4. So the total height I got is 52.8 meter. So this is the total height. So after that, what I did, as I told you, I divide the value. So I got the 52.8, and this one I divided with 12, because we have 12 floors we have considered from basement to ground roof level. So I divided with 12. So I got the final answer of 4.4 meter. So here I entered the same value, the 4.4 meter I converted to inches. And finally the important thing, now it is done. So the leakage rate of the stairwell, this is one of the important thing for us. So this table you can find from NFPA 92 smoke management system. Here the leakage rate is given for walls and floor. For example, here the staircase walls given, elevator soft wall which is used for the lift pressurization. I will cover that in the other coming classes. So in the lift stairwell walls, that is what we are doing. So here you can see it includes the construction cracks, but excluding but not cracks around the window and the doors. Okay, so that is not covering the window and the door crack. This is for the stairways wall, the construction cracks. For example, if you see the new building, so what will happen, it will be a tight building, like there will not be much leakage will be there. So when the building is getting older, it will be there will be some crack will be there in the wall, internal cracks, and we will get some leakages. And loose building is for the very old building. So whenever you construct the new building, as per the concept, it should be a new tight construction. But if you see the tight construction, what will happen, for example, I consider one value, the length and width of the staircase, the total I am getting area 40 feet square, consider is the average one. So for the average you have to consider 0.11 into 10 to the power minus 3, and if you multiply with 40, the leakage rate is 0.0044, and if it is tight one for same area, if you see the leakage rate 0.14 into 10 to the power minus 4. So you can see the leakage rate is low. Compared with the average, the leakage rate for the tight building, it is low because the leakage is very low. So if you design for the new building, after 20 years the building is getting older, and that time if fire happen, if there is a leakage, if you consider the value with the tight, and after 30 years, if it is a older building, when the fire happen means that time the leakage rate will be high. So that is the reason always we consider even for the new building, always we go with the average construction only, not the tight one. Okay, so now for the calculation, I consider for the stairways wall leakage 0.11 into 10 to the power minus 3. So I will go to the Excel file. You can see 0.11 into 10 to the power minus 3. So the leakage area around the door opening, first door into the stair. So here you can see 2 into the height and width of the door into the leakage rate, that is 0.1. So this is the things for the leakage through the doors and frame. And coming to the leakage due to the stair wall. So stairwell, the leakage, the air will go outside. So that also we have to manage. So here you see the length, width and height I consider for the staircase wall. And finally the important thing, as I told you in this example, I consider 3 number of doors as opening at the time of fire. At a time, three doors will be open. So that is the reason we need to consider the opening velocity also. So normally what we are doing, Q is equal to A into V will follow. So this one also we need to consider. Then I will come to this point for second thing. So Q is equal to A into V means the area, means the area is the door area. The A2 is the door area, and this one, the 200 feet per minute. You can see this point. The extra air flow 200 feet per minute we are considering for the natural air. That means 1 meter per second or 200 feet per minute we consider for the natural air. So here Q is equal to A into V. The A is the A2 is the, you can see this formula is come from the area of the door into N2 means the number of door we consider for this example 3 door. No? So that one into 200 is the velocity. So total this is the leakage rate for the opening of 3 door. And coming to this concept of the leakage because of the door opening as well as the wall opening, you can see this formula. From this formula, and we need to know one more important thing here, that is this 0.05, that is the pressure differential between the stair and the inside pressure differential. So here I consider 0.05 inch of water column. This one I took from NFPA 92, as I told you earlier. For the sprinkler building, minimum we need to consider 0.05 inch of water column or 12.4 Pascal. If it is the building with non-sprinkler, based on the ceiling height we need to consider. Okay, so in our case we have the sprinkler building, high-rise building, so I consider the minimum pressure difference of 12.4 Pascal at 0.05 inch of water column. So same I consider. In some project I was instructed that with this minimum value you go with minimum 4 Pascal higher or 5 Pascal higher also. If your client doesn't have any special requirement, you go with as per NFPA 92, you can consider 0.05 inch of water column as it is. So finally if you apply all this value in the formula, 17.9 plus A1 means you see the length crack area around the opening of doors, plus A is the crack area for the stairwell, plus the pressure differential by 1 by 2, I mean the root of P, into N1 means how many number of door you have. So that if you have total number of door, you have that much crack area will be there. So we have total door in our case. So we have to consider, we have to multiply with that one. So finally you got the leakage rate because of the door opening, because of the door and frame gap, and leakage rate because of the stairwell, and you got the number of doors opening because of that losses of the airflow. And finally if you add all these two, you will get the answer for the fan airflow. Additionally, we are going with 5% safety for the fan airflow. So 17305.70 is the capacity for your fan. So if you convert this one, if you convert this CFM to liter per second, you will get 8169. And here one more important thing you have to see here, the leakage area because of the door and frame. In our workout, if you see the formula here, okay, here I consider 2 into H plus W. C is the leakage rate. You can forget about that one now. So 2 into H plus W I consider because, see, in our case the door what we have, if you see for example this one, it's a single leaf door. Okay, so if we have two type of arrangement. If you have a single leaf door and double leaf door. So for example if you say it's a single leaf door, that means the leakage will happen from this gap and this side gap, and the below bottom this gap, and also this side gap. So that is the reason in that formula I multiplied 2 into width into height, width plus height. So we have one more cases also. We have the double leaf door. So most of the cases we have that one also. For example, this is your door means, and here it will be opening like this. It will open like this, like a double leaf door. So if you have that type of cases, the leakage rate will be this width into plus this width, and the height you have to consider 3 points. This is height 1, this is height 2, and also height 3. So additionally the center that area also will come in the leakage we have to add. So if you have means like this type of arrangement, so what you have to do, you have to apply this formula. You have to apply this formula and the answer will come. So if you have double leaf door, so you can replace at this point, you can replace this formula. You can just copy paste their formula, the answer will be different. So this is the way to find out the flow, and we are not finished yet. So we have, as I told you, we have one more very important thing here, because every authority is compulsory that you have to show that the opening force, because you know when fire happens, every people will try to escape from the fire route. So the opening force must not be very high, so the people cannot open the door. So we have to prove that the opening force is less than 133 Newton or 30 pounds is not exceeded. So here in our case, the maximum allowable force is 30 pounds or 133 Newton, and you know one by one we'll discuss about these values. So the first one, FTC. So FTC actually it's a very important thing, because the force required to overcome self-closing mechanism. This is very important, because you know what is this actually. So suppose you have a door and you are just slightly opening the door. So if you open the door, what will happen? The door will try to close automatically. It will close slowly. So because that is a self closing, because the self closing for steel door and different door is different. So mostly we will consider the self closing mechanism as 12 pounds. 12 pounds, and coming to door width, it will automatically come from the left formula. I'm just convert to feet, and door area also it come from the left. Already we entered the area, so it automatically comes from there. And pressure differential also we already put there, 12.5 Pascal or 0.05 inch of water column is coming from there only. And distance from knob to the edge of the door. So this one. So if you see here, we are now talking about the distance from the door knob to the side of the door. So this point, we are talking about the D here. So where we are opening, the knob is located from here to the distance of means the end of the door. So this distance is very important, because why? You see the formula is normally torque is equal to applied force into distance. So if this distance is increased, so if the distance is increased, the knob is located here or here. So if the distance is increased, the force into D, that applied force will go high. So that is the reason normally this item is normally considered for all the calculation. And this is normally we have one constant value that we follow for all the calculation, because normally this door is located in the end only. It will not be in the middle, or it will not be in the side only. So that is the reason this value is means we are keeping like a constant value, 0.25 feet. So this one, if you go down into our notes, I mentioned this one clearly. If you see here, this value normally, this gap between these two is 3 inches or 0.25 feet. So this one we can apply. So if you want, you can just verify with your door manufacturer. But in the initial stage of the design, when you develop the concept design or IFC, that time the door manufacturer is not finalized. So that is the practical reason I always choose this 0.25. This is acceptable mostly 0.25 or 3 inches. Now this formula automatically the answer will come. So you can see the answer, it is 15.4 in pounds. The answer is in pounds. So we should not exceed 30 pounds, and the answer here is 15.4 pounds. So this is the acceptable limit. So we selected the flow capacity, the fan capacity, and also we selected the door opening force, we verified. So this is how you have to submit your documents to the authority. It will get approval. Okay. So you have to submit with some backup documents like the drawing what you followed and this thing. So the stair is big or small, how high the stair, whether it's a medium rise building or high rise building, the concept is very clear. You have to follow how many number of doors and the other parameters as I mentioned in the stair, the Excel file, and you can easily solve this calculation. So now you can ask your doubt one by one. I will solve that all.